Kia ora koutou. I'm making this video mainly for people in my tutor group who are doing the Level 1 external exam next week. This is tables, equations and graphs from 2020 and it's question 2. It's the merit and excellence parts of it. So I'm going to start off by doing a bit of revision on the 3 different ways that we can write and draw parabolas. The first one we're going to look at is the expanded form of a parabola. So the equation of the graph drawn here is y equals 3x squared plus 4x take away 2. And when we have an equation written in this form, it looks really easy, but it doesn't give us that much information. It tells us the value of the y-intercept. It also tells us how stretchy or squeezed in this parabola is going to be, right? But the most useful bit of information when it's in expanded form is that I know that when x is equal to 0, y is equal to -2. So the y-intercept is at -2, and you can see that here. Now, how do I know that? Well, I'm going to substitute in 0, and that gives me 3 times 0 for that bit, plus 4 times 0 for that bit. And it will always have that pattern, right? If I choose 0 to substitute in, and then I've got to take away 2. So the other thing that's good in here is I know that that 3 is giving me information about how stretchy or squeezed my parabola is. So bad graph drawing time, guys. The basic parabola graph, which is just y is equal to x squared, you know looks roughly like that. I've got stylus shake condition today. I don't know why, but hopefully your graphs look smoother than mine. If I've got y is equal to 3x squared, what it does is it squishes everything in more like that. Okay, so we do get information from this coefficient here as well. But basically, expanded form, it's good for giving me the y-intercept. The next one we're going to look at is what we call factorized form. So here we've got the graph of y equals 2 times x minus 3 times x minus 7. And when you've got it written out like this, you get information about where the x-intercepts are. And they're at x equals 3 and x equals 7. So what's going on? Well, when x is equal to 3, we have y is equal to 2 times 3 take away 3 times 3 take away 7. This one here is 0. So that means that the whole thing will be 2 times 0 times whatever, and that gives me 0. So that's the first x-intercept. We can do the same thing with x equals 7. We'll have y is equal to 2 times 7 minus 3 times 7 minus 7. This bit here will be 0, so the whole thing will be equal to 0. So that tells me that I've got 2 x-intercepts, and here they are at 3 and 7. The other thing that's good is, again, that 2 number is telling me about the stretchiness of the graph. That's what we call the scale factor. The other thing that we can work out if we do have factorized form, which can come in really handy, is that we know that parabolas are symmetric, right? So if I know that we've got one x-intercept here and the other one here, we know that the graph is one that's the right way up. Then if I go halfway between those 2 points at 5, that's where the vertex is going to be. So I can take this x value and I can substitute it in here to figure out what is that number there, right? So in this case, it'll be y is equal to 2 times 5 minus 3 times 5 minus 7, which gives me 2 times 2 times -2, which is -8, which matches up, of course, to what I've got in that graph. But if you were having to draw that graph from scratch, then that's a really, really useful thing to have a good understanding of. Okay, the third one that I'm going to show you is vertex form, and in my experience this is the one that Year 11s like the least, but it comes up all the time, so we want to get really, really comfortable with it. So this graph is y is equal to -2 times x minus 3 squared plus 5. I have deliberately chosen a negative scale factor here because in this question that we're about to do, and in lots of questions in real life, we're going to have an upside down parabola if we're dealing with any kind of throwing a ball or throwing a rock off a cliff or jumping into a swimming pool or stuff like that. Right, so we've got a negative coefficient here, which is giving me this shape. If we had a positive one, it would be like that. Then the next bit of the equation is telling me where is the x value that's going to give me the vertex or the maximum point on the parabola. And you can see that in here, if I have x equals 3, this thing here will be 0. So the whole thing will be y is equal to -2 times 0 squared plus 5. which gives me my vertex of 0 plus 5, which is 5. So the vertex will be at 3 and 5, right? So here's that 5 number sitting here. That means that whenever I've got an equation in vertex form, for example, if I've got y is equal to negative 0.1 times x minus 2 squared plus 7, I can look at that and I can straight away say, hey, the vertex is going to be at 2, 7. So that's going from the equation to the graph. But even more useful, especially in level 1, is when you need to work the other way. And this is the lead into the question. See, we are finally going to get to do this question. Suppose that I didn't give you this equation here, right? So that's not there. Pretend you can't see it. And you look at that graph and you have to figure out some information about it. Well, the first thing I notice is that I don't know what the y-intercept is, right? I've got no clue what's going on here. I don't have any nice factors here to do factorized form. But what I can see is, if you're in my Year 9 class, you'll know that I call these blobby points, right? So I've got a vertex here, and the vertex is at 3, 5. So that means that if I want to write the equation of this graph, it's going to be this. Y is equal to some scale factor that we don't know yet, right? This is really important, right? We don't know if it's like this, or if it's a really squeezed in one, or a spread out one. So we're going to call that scale factor K, and then we're going to have X take away 3 squared, right, because I know that my vertex is at 3, and I know that the y value of that vertex is at 5. And that's really, really useful, because now we can start to figure out the equation of the curve. What we've got to do now is use some other information to work out what k is. In this case, what I would use, I'm not going to finish this, but what I would use would be this point here, right? Or this one here. So I look for a blob, what I call a blobby point, a point with integer values, or just some information on the graph. So now let's go back and do part 1 of question C, and you'll see that we're dealing with exactly the vertex form that I've just been going on about. There are a lot of words in this question, but luckily there's a really good picture. So Tane is practicing his volleyball skills by throwing the ball over the net. The net is here. The net is 2.4 meters high. That is completely irrelevant to this question, by the way. Okay, Tane is at a horizontal distance of 3.2 meters from the net, right? So the net is here, so he is back here at negative 3.2. And the examiners have very nicely given you the coordinates of that point. And he hits the ball from a vertical height of 2.3 meters. So even if they hadn't given you that point, the first thing you'd do with this question would be to write that point on there. The ball travels in a perfect parabola shape over the net. It reaches a maximum height of 4.8 meters, so there's your clue word for the vertex, when it is at a horizontal distance of 1.8 meters on the other side of the net. So that's a long way of saying this, right? The maximum height has been given to us here. And as soon as I see that, I think I need the vertex form, even kind of before I know what's coming up. Because we haven't got an equation here, getting an equation will help me solve the problem. So the ball is going to go whoosh over here and it's going to land here. Right, find the equation of the path travelled by the volleyball as it leaves Tane's hand and heads over the net, as shown in the diagram above, blah, 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 blah. Right, well, if we know, and we're going to call h the vertical distance, so this is y is h here, so h will be some scale factor k times x minus 1.8 squared plus 4.8, right? It really is that fast once you're confident with vertex form. So this is a merit question, and what we've got to do now is to figure out k. So we need another bit of information. This is no use to me. This net is not on my curve, right? Otherwise the volleyball would get stuck. This point is what I'm going to use. So I'm going to substitute in 2.3 for h, and I'm going to substitute in negative 3.2 for x. So negative 3.2 minus 1.8 squared plus 4.8. Right, now I'm going to do this slower than some of you probably want me to if you're just hanging in here for the excellence bit, because there are a few things that can go wrong in here, and the main one is when I'm squaring a negative number. So we've got 2.3 is equal to k times negative 5 squared plus 4.8. 2.3 is equal to 25, whoops, I'll just turn off into shape in OneNote. So 25k plus 4.8. Now I'm back to year 9 algebra, right? I've got a two-step equation. I'm going to subtract this from both sides of the equation, and that's going to give me negative 2.5 is equal to 25k. And now I've got 25 times a number. I want to just have the number. I'm going to divide both sides by 25. So negative 2.5 over 25 is equal to k. That gives me k is equal to negative 0.1. And so don't leave it like that. Let's write the equation out nicely. That gives me the height of the volleyball is equal to negative 0.1 times x minus 1.8. Oops, done it again. X minus 1.8 squared plus 4.8. Okay, and that's my final answer for that question. Now let's just check that that's all we had to do. Yep, that is. We had to find the equation of the path. So now we're going to look at the next one. I think I'll have time in 4 minutes. I might have to go on to a part 2. So here's the second part of the question, and it does help if you have understood the first part well. Actually, I am going to do a second part here because it turns out there are 3 ways that we could answer the question. There's one that's very precise that I prefer, and then there are 2 others that use graphs and use tables. So this time we've got Ruru joins Tane standing on the opposite side of the net. Tane sends the ball over the net towards the Ruru. The equation of the path travelled by this volleyball is given to us this time. Look, it's given to us and it's in vertex form. Okay. Ruru dives to reach the ball before it hits the ground but misses the ball. So find out how far away from the net the ball will first hit the ground. Let's look at what's going on. What are we trying to do? Well, we know that, so we had in our first graph, we had Tane here, but this time we know that Ruru is over here somewhere. And he's going to miss the ball, right? So what have we got? Well, we've got some kind of path here given by this equation. So things that I can see here is that, this is a bad graph, right? I'm going to get rid of this, but it's going to be something like this. And I'm asking, what is this point here, right? Where does the ball hit the ground? And we know that this one is at 2.1 here and 3.9 here. So I do want to draw that quite nicely, which is definitely going to take me more than 2.5 minutes. But for now, I'm going to do this with that bad graph and show you what we're going to do to figure out the answer here, because I actually don't need a really good graph to do this question, as long as I've got enough of a visualization. Okay, so we know that the vertex is at 2.1, 3.9, and we've been given the equation this time, so we've got the scale factor and all of that stuff already. H is equal to negative 2.5 times x minus 2.1 squared plus 3.9, and we want to know when's h equal to 0. So substituting that in, we get 0 is equal to negative 0.25 times x minus 2.1 squared plus 3.9. Negative 3.9 is equal to negative 0.25 times x minus 2.1 squared. Now I'm going to divide both sides through by this. We get negative 3.9 divided by negative 2.5 is equal to x minus 2.1 squared. This gives me 15.6 is equal to x minus 2.1 squared. I take the square root of both sides. Okay, so what's the square root of this? Well, it's rounding it, it's 3.95, but it could be either the positive or the negative square root. So I'm putting that plus or minus in there, right? And that equals x minus 2.1. So the last thing I've got to do is to figure out what x is. So I'm going to add 2.1 onto both sides. So we get 2.1 plus or minus 3.95 is equal to x. That gives me two values. X is equal to negative 1.85 or 6.05, but we know that this is the one we want, right? Because we've got enough of a picture to know that it's an x greater than 0 value, because we've got Tane back here and we've got Ruru somewhere on this side missing catching the ball, right? So in here, we can reject this one here. Okay, so we're going to reject this one here, not valid, right, in context, and it's going to be this one here, x is equal to 6.0.